Hey, students, Mr. Zacek here, and we are moving along in Unit 3. We're in Lesson 2, and Lesson 2 has kind of 3 sections to it. So this is the second section. Last week, or last lesson, we were talking about when you've got parallel lines and they're cut by a transversal, then we have different kinds of angle pairs that we know are proven. And so this first thing, I'm just going to basically, this is just a review of our proof terminology, and I want to show you what conclusions we can make. So basically what we're talking about here is given parallel lines cut by a transversal, what conclusions can we make in a proof? So what conclusions can we make? And we've got 3 really simple ones and then one that's a little more complex here today. So I'm just going to use this 2-column format because it helps us to organize what are our statements and our reasons. Okay, so obviously we very often are going to start with what we're given, and L is parallel to M. Now you'll notice that the L, that kind of italicized L, or the cursive lowercase l, we don't want to confuse that with the number 1. That's why we make that the L. Okay, so in this case here, what we want to recognize here is that 1 and 2, this is a pair of, okay, these 2 angles are what we call corresponding. All right, so they're on the same side of the transversal. One of them is an interior angle, one is an exterior, and they come from that top grouping and bottom grouping. So we can say that they are going to be congruent to each other. And here's the reason why. It's just from our notes last time. So if 2 lines are parallel and cut by a transversal, I always think of Shakespeare when I think of cut by a transversal. So if I say it like that, if 2 lines are parallel and cut by a transversal, then corresponding angles are congruent. So corresponding angles are congruent. So if we have that, we can make that conclusion. Statements are always going to be specific to the problem. Reasons are always going to be general. Essentially, we're just giving definitions here for those. Okay, so let's look here. In this setup, angle 1 and angle 2 are alternate interior angles. And if 2 lines are parallel and cut by a transversal, then the alternate interior angles are going to be congruent to each other. Let's put a little color in here. So we have statements and our reasons. So we can say, again, L is parallel to M. We know that's true because it's given. What conclusion can we make? We can say that angle 1 is congruent to angle 2. All right, so here's the reason. If 2 lines are parallel and cut by a transversal, then what angle pair are these? Alternate interior. So alternate interior angles are congruent. And it's okay to put the congruent symbol. It's okay to put the angle symbol. Just make it so we don't think that it's a triangle when it's the angle. Okay, now there's some different. I'm going to show you I'll show you one way to do this, number 3 here, and then I'll talk about another way to do it. So in 3 statements, okay, reasons, we're trying to prove that angle 1 is congruent to angle 2. Now, one of the reasons that we had said the other day is that alternate exterior angles are congruent, and that is a reason you could go there, but I'm going to kind of show you another way of getting there. And so we've got L parallel to M, all right, so that is given to us. All right, now the next thing I'm going to do here is my freebie, and my freebie is that 1 and 3 are vertical angles. So angle 1 is congruent to angle 3 because if 2 lines intersect, then they form congruent vertical angles. If 2 lines intersect, then they form congruent vertical angles. My board is going nuts. Okay. So, if 2 lines intersect, then they form congruent vertical angles. That's for free. Now, we also know that because the lines are parallel, angle 3 is congruent to angle 2. So, angle 3 is congruent to angle 2. And that's because they're parallel, and that pair of angles is corresponding angles. So, if 2 lines are parallel and cut by a transversal, then corresponding angles are congruent. Okay. Now, what I want you to notice here is in this reason here, so 3 and 3, those are the same. So what can we do? Well, we can go ahead and say that angle 1 is going to be congruent to angle 2, and that is going to be either the transitive property, or you could use substitution. Either one of those would work for that scenario. Okay, so again, one of the reasons we do this is if we don't have to remember as much, you don't really need to remember the exterior angles. If we remember corresponding alternate interior and same side interior, then you can get to the exterior angles. And so some of you are here and like, couldn't this have just been a one-step proof? We could have said angle 1 is congruent to angle 2 because if 2 lines intersect, then they form congruent alternate exterior angles. Yes, you could have done it that way, but here's another pathway to get there. And so especially sometimes when we have these fill in the blanks, we want to look at some of the different pathways that we have. So again, this here, number 2, this is what we call a freebie. Okay, you get that just from the diagram. Okay, now we got one more on the back here, and given that A is parallel to B, we want to prove that angle 1 and angle 8 are supplementary. So let's recall that angle 1 and angle 8 supplementary. That means they're going to have to add up to. So really what we're trying to get to is the measure of angle 1 plus the measure of angle 8 equals 180. Then we can make that statement. So let's go along here. All right, A is parallel to B, given. All right, angle 1 and angle 5, those are corresponding. Okay, so this is a pair of corresponding angles. And what did we just say in step 1? We said that they're parallel. So if 2 lines are parallel and cut by a transversal, then corresponding angles are congruent. Don't leave that congruent part out. That's a part that people often leave off. Okay, now the measure of angle 1 equals the measure of angle 5, and that's simply this. If two angles are congruent, then they have equal measure. Okay. All right, now we want to come back up here, and it says angle 5 and angle 8 are supplementary. Well, angle 5 and angle 8, that forms a linear pair. So what we need to recognize along here is that 5 and 8 are along this line right here, and that means that these two angles, that's a linear pair. And linear pairs are supplementary. So the reason for this is if two angles form a linear pair, then they are supplementary. Okay, so supplementary. So the measure of angle 1, or excuse me, the measure of angle 5 plus the measure of angle 8 equals 180. Well, that's really the definition of supplementary. So if two angles are supplementary, which we just said in the previous statement, okay, then they add to equal 180. Equal 180 degrees. Okay, so now how do we get to step 6? How do we get to the measure of angle 1 plus the measure of angle 8? Well, if we look at step 5, we've got the measure of angle 5, and back in step 3 we said the measure of angle 5 equals the measure of angle 1. So what we're going to do is we're going to replace that by substituting. So that's simply the substitution property. Substitution spelling, like my brain just stopped working or something. Okay, substitution. Now, what's the last statement is always the thing we're trying to prove. So we're trying to prove that angle 1 and angle 8 are supplementary, and we know that it means that if they add up to equal 180, then they're supplementary. So the last statement is, this is always the proof is going to be our last statement. So the reason is, well, if two angles add to equal 180, then they are supplementary. Okay. All right, and we just said in the previous step that they add to equal 180. Okay, so we're setting up the building blocks here. This is kind of, the most basic type of parallel line proofs. And in the next lesson, we'll just get a little bit more advanced and keep building on this. So good luck with your assignment.